Hello guys, welcome to another episode of Xa Talk Show. Today we are going to do live coding of Wolfram language of geometric inversion. We are going to continue yesterday. You can see this graphics is what we did yesterday. So start a Wolfram language, open a new notebook, paste it, and shift enter to run it. So you can see this is what we did yesterday. So today we are going to continue this and we are going to do a three-dimensional geometric inversion. So you see this is a two-dimensional version. You start with a grid like that, two-dimensional 2D grid with tubes. Then you apply the geometric inversion, which is a function. Then you get this three-dimensional beautiful figure. So today we are going to do a three-dimensional geometric inversion version. So let me show you. So if you have not already watched yesterday's YouTube, my live stream 2 days ago, a day, the previous one. So you can see. So here is a 3D version. Let's copy the code. So this one you are seeing is a geometric inversion, three-dimensional version of cubes on a grid. So you start with a bunch of cubes, then you apply the function, then you get this beautiful image. Okay, and today what we are going to do is instead of cubes, we start with a cage, three-dimensional grid of lines with tubes. Then we invert it, so we will see a beautiful image. Okay, and today, and let me paste the code. Control-Shift-N to make it beautiful, like typesetting, typeset mathematics. Then Shift-Enter to run it, so you can see. So here is the image. You can see the beautiful nested circles pattern. Okay. So let me tell you, so I'm using a new keyboard. I did a video about 2 videos before, last week, basically. So you can see I'm using this keyboard I'm using is Glove 80. So I have so you just search for Xa keyboard blog and you'll see the Glove 80 keyboard, that one. Okay. So I did a review of it about last week. You can go watch it. The video is also shown here at the bottom. So it's a fantastic keyboard. I recommend it. Okay, so here's a video 2 days ago, last week. Okay, so it's great. I'm still not used to it yet, and I have not programmed it yet. It's programmable. So, for example, Windows space. Right now I'm using the Windows Vorak layout. So it might be slower than my usual coding. Okay, so I'm using Emacs and I'm using Xafly keys, which is you can search it, Xafly keys. You can find it's a Emacs key binding system. So that you don't have to press Control, you don't have to press Meta or Alt. Every command you can see on the pink window, that's my command calls and keystroke. I'm using a Vorak keyboard. Okay, so let's begin coding this. Okay, so hold on a second. Copy that back to Emacs. Open last closed. Close it and put the link here. So show in browser. So this is today's talk show, and put the link here so people know. So they can come back and see, what is the keyboard. Okay, so geometric inversion, fantastic. Now, cube. Let's begin to code it. If you have questions, comments, post it. Okay. So begin a Wolfram language, Xa Wolfram mod, which allows you to code Wolfram language in Emacs. It's also free on GitHub. There's a link, Xa Wolfram mod. Okay. Okay, so now let's start to code it. So the first thing we want to do is to create a grid made of tubes like that, but three-dimensional. Okay, so essentially the code is almost very similar to what we did yesterday. So so why don't we just copy the code here, copy it back to Emacs, paste it here. We're gonna modify this code. So the first thing you want to do is, so here is the function. Here's a geometric inversion function. It basically takes, let me paste it, so let me magnify. Okay, so what this function do is basically, let me just show you what it does. It just take a point and return a point. That's it. A point being two numbers, or in 3 dimension, it's 3 points. Represent the coordinates of of a point in 3D. It can be 4 dimension or 5 dimension. So, for example, let me show you geometric inversion. So Shift I and V. So that is our function, and where is my square bracket key? So I'm not too used to this keyboard yet. This is maybe not a good idea. Where is my? So I need the square bracket. Oh, okay. Okay, one of them is there. The other one, oh, okay, they went there. Okay, so this is Borac mapping via Windows on this special keyboard. So geometric inversion. Okay, so now you need shift. So for example, Shift Enter. So essentially, that's what that is a formula. So if you have, given a point AB, a vector AB, and this is the result. Okay, that's a geometric inversion. That's just a function. That's all there it is. So, but you can also have a 3-dimensional vector. Shift Enter. So in a 3-dimensional vector, you just, it returns a new vector. So, and it can be 4-dimensional or higher dimension. So that's a geometric inversion. Now, if you want to know more about it, you can just go to the, go to, my website. Watch, I did a video last year, so you can see this video where I explained, we did that one. We explained what is a geometric inversion here. So it's just, for those of you programmers, it's just a function. Takes two numbers. Takes one number, returns a number. Two numbers. A vector, a point. From a mathematician geometer point of view, it inverts. It's kind of like a mirror, but it inverts points inside a circle to outside, and outside circle inside. So it kind of swap. Like if you have a piece of paper, you poke a hole in the middle, and you kind of imagine the piece of paper is rubber. You swap it inside out, so the outside edges becomes the whole edge in the middle, and the middle becomes outside. That's inversion. Very interesting concept. Okay, so you can read about it on this page. Search for Xardi plane curves inversion, geometric inversion. Okay, so that is a geometric inversion. So that's essentially just that's all it does, that function. So now, this is a function. By the way, if you are wondering what is this, the first part, that is for, the geometric inversion is not defined at the center of the circle. So if you at the origin 0, 0, that point is not defined. So ideally that point goes to infinitely outside. So anyway, so that is why in the code you have to check if that the length of you want to check the input numbers AB or ABC or ABCD, they are all 0. If they are all 0, then it's not defined. That's why you have the if statement. Okay, but this is essentially what it does. Okay, so this here is the function geometric inversion. Then now the first thing we want to do is create a three-dimensional cube of tubes. Okay, so how do you do that? Okay, so yesterday we explained. Let me get these two. So this is the syntax for the tube. You can see. Let me show the documentation for the cube, Wolfram language. Okay, turn on JavaScript. So this is how you represent a tube. You just call the function tube and give a list of points. Then it represents a tube connecting to those points. Okay, so it's very high level, powerful Wolfram language. So you have so here is a tube, and what this table do is that it takes any expression, then it just iterate. It's like Python's it generated nested list. Essentially, it's like Python's how do you call that? Anyone watching? So let's go to Python. Python. Okay, so this is similar in idea. It's like a nested loop. Okay, nested loop. But in Python, you have a special method to generate it. A special syntax called list comprehension. Okay, that's very silly. So list comprehension, Haskell also calls that, uses that, but that's no good. So, but anyway, table is just a list comprehension. It allows you to generate a nested list without using nested loop syntax, which so this is a functional syntax. So actually, why don't we just show it? For example, x, let's say x from 1 to 5, okay? And let's do another case. In this case, let's say x and y, x from 1 to 5, and y from, let's say, -3 to let's say 0 in steps of -1. Okay, so if I run it, you'll see what it does. It just generates a nested list. Okay, shift enter to run it. Okay, so the first example is 1 2 3 4 5. The second example, we got something wrong. Oh yeah, this should be y, so let's change it y. And what? -3 to 0. Oh, instead of +1, we got the sign wrong. So shift enter. So there it is, nested list. That's what table does. Okay, so table. So we call table. Then we put table here, and here is a tube. We want to call a table, and x from. Let's see where the x and y. X from, let's just say 0 to 5, okay? Let's just say 0 to 5. And similarly for y, okay? And here we want a tube. So this is a three-dimensional case. So we actually need also Z. So we want a three-dimensional nested list. In other words, a 3D matrix. Okay, x goes from 0 to 5, y 0 to 5, z 0 to 5. Okay, so and here you can just say, for example, let me just show you example. Let's say f x y z. Okay, so this expression. Okay, let's show you what it does. Okay, shift enter is that key. Okay, so you can see XYZ wait, why is so what is X? Did we define it somewhere? Y Z. Okay, so table f x y z. Oh, we forgot a comma. You see, we forgot a comma there. So the first argument is the expression. The rest arguments are the iteration. So you want x goes from 0 to 5, y goes from 0 to 5. Okay, and similar for z. So now shift enter to run it. There it is. Okay, so you can see the first row f000, f001, 002, and so on. And then we can format it in a better way by saying you want // table form. Okay, so that means apply the function table form to the previous expression. That's what the // operator is. That's a postfix operator. Okay, now run it, shift enter. Okay, so let's see if it makes sense. Okay, so you want to enlarge the window. Okay, like that. Okay, that's what nested, nested matrix. So anyway, so that's a table. So here, instead of the fxyz, we want a tube. Okay, now let me show you an example of tube. Okay, so tube takes one argument, a list. Okay, and each element in a list is a three-dimensional vector, so 3 numbers for the coordinate. Let's say 0, 0, 0. Okay, and the second number, let's say 0, 1, 0. Okay, so that's a tube. Then if you want to render it as a graphics, all you have to say is you just put graph 3D in front. Okay, okay, so copy that back to Wolfram language, go to the bottom, paste it, shift enter to run it. Oh, not graph 3D, graphics 3D. I always typo. Okay, so copy it back to Wolfram language, paste it, shift enter, run it. So you can see there is a tube, and the second argument to a tube is the radius of the tube. So you can say 1. Let's shift enter. Oh, this is long PO tube. Okay, that's too thick. 0.1. Okay, control enter and shift enter. Yeah, so there it is, a tube. Okay, that's the syntax of the tube. the graphics 3D that just render it. So this graphic 3D is similar to print. Usually in programming languages, when you say print, it prints text. But if you want to print graphics, that's what this graphics 3D function is. So we got the syntax of the cube, and now we covered the syntax of the table. Now we just want to use the table to generate a huge amount of cube, like forming a grid, three-dimensional grid. Okay, so how do you do that? Let's see. So in order to do that, let's try to do it here. So first of all, so you want, so if it's a square, then it's very easy. You just start here, go here, go here, go here, and one more point, the first point. Now if it's a square, you cannot traverse all the edges of the cube in one shot, so you need two cubes. Do I make sense? Hello, Benjamin. So yeah, so you have to think about how do you. Okay, let's try to do this. Okay, x, y, z, the first point. How do you want to do this? So a cube's got 6 points. So the problem right now is that you are given a point xyz generated by the table. You know, for each iteration, you are given a point xyz. You want a cube. You know, so from that point, you have 6 more points, because that point represents a corner of the cube. So you got 6 more points, okay? And what you want to do is that you want to call cube connecting each end of 2 points, forming a cube made out of cubes, okay? So given a point, okay, so let's why don't we start to just write this? Given a point, what are the 6 corners of the cube? That's easy. That's just a combination. So how many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges, okay? So the first one is that. Let's just do this, okay? Let's just do. Oh, God. Let's do each edge one by one. Oops. Plus, where is plus? Plus. That's the key. Okay, sorry, I need to find my plus key. Okay, so plus 1, okay, 1. So that forms one edge. So actually we need some kind of, we need to draw it, because this is going crazy. Here's my tablet pen. God. What? Oh, here. So, am I doing good? Oh, we got 4 people watching. Okay, so first of all, we this is getting confusing. So let's draw it. Let me just draw it. Okay. So a cube, let's say like that, okay, kind of like that. So you got, this is X, well, this is origin. So you got, let's say A, B, yeah, this is pretty cumbersome. C, D, E, F, G, H. So you got 6 corners. What you want to do is that you are given a corner A, you want to generate the rest of the corners. Then you want to, for each 2 corners, you want to group them together to make a tube. Okay, so that's the problem. How do we do it? First time catching a stream, just want to say thank you for inspiring me to learn Emacs. Oh, delete it. I cannot see it. Love you, man. You are awesome. Thank you. Okay, so thank you for inspiring me to learn Emacs over the last couple of weeks. Fantastic. Okay, so yeah, so let's get back to work on this. So, okay, focus. So we want to do this. The thing is, okay, so we are given X, Y, Z. What are the other points? Okay, let's write down the other points first. Okay, so let's say A is that, okay, A, B, C, let's just name them A, B, C, D, yeah, F, G, H. Okay, now B would be that, C would be Z plus 1. Okay, D would be X plus 1. Okay, and E would be X, Y, X, B is wrong. So how am I drawing? I'm using Microsoft Snip and Sketch. In Microsoft Windows, when you do a screenshot, you'll open in kind of the drawing tab, this application. Okay, so that's how you can draw it. And of course, I'm using a tablet. You search for Xali keyboard blog, you'll see my review of a bunch of tablets. Very useful if you are taking notes or do mathematics. So anyway, let's focus on this. So, I failed to mention, if you want, we are doing Mathematica Wolfram language. You can get it for free if you just go to my website, Wolfram language tutorial, and download for free. Then you can do what I'm doing. by default, you don't get graphics, you don't get a notebook, but you can download the notebook from the open source Wolfram Jupyter Notepad, so you can integrate them. So you also, so you can do what we do. Wolfram language, okay? Search for Xadi Wolfram language tutorial, you'll find it. Okay, so now let's go back to doing this. Okay, point B is x plus 1, y doesn't change, okay, and z doesn't change, okay, yeah. Point C is x plus 1, yeah, actually, and y doesn't change, and z plus 1, okay, and point D is x doesn't change, x doesn't change, y doesn't change, z plus 1, okay, and EFGH, point EFGH, their y is all plus 1, EFGH, okay, so y plus 1. Okay, now x no change, y plus 1, z is 0. Now f is x plus 1. We can probably do this in a permutation kind of fashion to generate this, or this where you should have a plus 1. So f is x plus 1, y plus 1, z stay put. G is z plus 1, g is x plus 1, y plus 1, z plus 1, yeah. Oh, if we think of traversal, it's much easier, okay? So h is h is x stay put, y plus 1, z plus 1, okay? So that is the 6 points of a cube given one point x, y, z. Okay, so given 1 point, we generate all these bunch of points. We don't want this, actually, so that's a comment, okay? So actually, let's do this. Let's add a comment. Okay. Okay, so that's a comment. Now the whole thing, we want to make it a list. Okay, so we got a list of these points, okay, and we need a comma at the end. So since we have a list of numbers, okay, and corner to cube points. So we can write a function. Given a point, that's a corner of a cube, to all the corners of a cube, okay? So once we have these 6 points, we need to kind of connect them. Okay, this is fairly tedious. You cannot just connect arbitrary points. We could if we want, actually. we could. Then we're gonna generate some interesting interesting things, that, like, for example, there would be a cross in each of these square. But for now, let's not. Okay, now you need to pair them. Okay, but anyway, once we have these then it should be easier to pair. So A connects to B. Okay, so A connects to B. Okay, so AB, BC. Yeah, okay, so this is tedious. That's AB. That's BC. Then CD. Okay, CD is these two. CD. Then DA. Okay, then DA. Okay. D A. Okay, we don't need that. Then, oh God, FG. Okay, FG. EF. Okay, EF is a pair. GH is a pair. Okay, then we also EF, GH. Then we need HE, GF. Okay, HE. HE and GF. Okay, so we need GF. GF. Okay, so you know, ChatGPT is very interesting. In fact, I got, you know, some people, I asked people, they wrote a poem about my website. You know, it's amazing. So I watched, so, you know, if you want the review of the Glove 80, watch my 2 videos before. So I did review on that. Okay, so let's focus back on this AB's. Okay, so we got AB, BC, CD, and CA and DA. Okay, so this part is wrong. This should be DA. Wait, what? CD and DA. Oh, okay, DA. Yeah, so DA. Then EF, we got EF, we got GH, EF, let's see, let's say EF, then let's say FG, let's go circular. Okay, FG, then GH, then we got GH, then we got HE, then we got HE. Now it's circular. Okay, now we need the, you know, those lines there. Then we need BF. Okay, let's split again. BF. Okay, then CG. Okay, CG. Okay, CG, then AE. BF, CG, AE, and DH. DH. Okay. D edge. Okay, that's a lot of work. Now we need to add the comma. Okay. Okay, in fact, each one of these pair should be a tube. So each one of these pairs should be a tube. So why don't we do it again? Okay, so yeah, so copy each one of these should be a tube. There, okay. So in fact, I can just there, okay. That the @ sign you are seeing, that's a prefix notation. So you can say add something argument, you know, instead of the bracket. So you can use @ sign. It's equivalent to a bracket. Okay, so here is a tube of 2 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 edges of a cube. Okay, so we got that. So that's essentially what we want. So we can actually put here. That's the expression. Okay, let's try it. Okay, let's just say, let's run this code and see what we get. Okay, so Wolfram language, yeah, let's try to put this here, paste it, remove the comma, shift enter. Okay, we got, I think we missing a comma or something. Check n equal length. We probably missing a comma somewhere. What's going on? Let's double check. How long we have been doing? Oh, what? Close to an hour already? Shit, I thought this should be faster. Oh, we forgot a comma here indeed. Okay, so now let's do again. Now let's, yeah, we forgot a comma. Okay, paste it, run it. Okay, oh yeah, we got the extra comma we didn't delete before. There, delete, run it. It worked. Okay, now all you have to say is graphics 3D at lots tubes. I'm not used to the shift key yet. Okay, so there, shift enter. Fantastic. Now we got something wrong. You see, we got you know, there shouldn't be diagonal lines, so we so we got something wrong. Yeah, we have to double check our so if you're gonna add diagonal lines, how many are there? 1, 2, 3, 4. You know, diagonal lines are actually interesting when we do these graphics, because you have it would be a very interesting effect for, for the thing we want to generate. This, because it will have very interesting effect. We are going to get some kind of spiral effect, but for now, let's fix it, I guess. So we got diagonal lines. Okay, now let's reduce the number of iteration. Let's just say 3. Okay, let's just say 2. Okay, 3, 2, 2. Run it. Okay, now it's much simpler. Yeah, we got 2 mistakes actually here. God. Yeah, I don't know. Yeah, we can fix it, but it's just tedious. Let's just go with this, okay? Let's just go with that. We're gonna apply a geometric transformation to all these grid points, okay? So now we got lots of tubes, and we can say tube graphics. Okay, so now let's just remove those. Pretty tedious. We got this. Let's comment that out. And this part is showing, what is this part? So tube, yeah, this part is showing how tube works, okay? Yeah, a bunch of points. So delete it, we don't need it. So this is an example of a tube, delete it. Wait, the comment went wrong somehow. Hold on a second. Yeah, the comment. Yeah, this is incorrect. Okay, let me do this comment. Okay, there. Wolfram language comment can be nested. So this is a comment, and you can nest it. Control G. So now this tube we don't need. Okay, so geometric inversion function. This is the prototype of the cube corners, and here's the actual code to generate tons of cubes with tube as edges. Okay, then you create a graphics out of it. Then you define the geometric inversion, which we defined here, so we don't need. Then you show the graphics. Then all you have to do here is you do a transformation, replace all. In Wolfram, Wolfram language is a term rewriting system. So half of the time when you do computation, what you do is that you tell it to do find and replace. So that's what this replace all function is. It does find replace of your syntax. In other words, it transforms your syntax. Whatever you typed, you can consider this whole thing or this whole data as just a bunch of data. For example, let's show the actual value. So evaluate, you see, that's the output, just a bunch of data. So you can think of this whole data as a string. Then the term rewriting just means you take this, consider this as a string. You want to find certain pattern and replace it by some other thing, just like string find replace, okay? Except you are doing it syntactically. It's not just, these strings are kind of alive, So that's the power. That's why Wolfram language is a symbolic language. You can think of this as a, Lisp macro is a bit like that, but it's like the most basic. So anyway, so what we want to do is we got this bunch of data. We want to find in this data, we want to find any pattern, any occurrence of these 3 points, just 3 numbers. When we find that, we want to apply this geometric inversion function to those points. Okay, then we'll get our geometric inversion graphics. Okay, very easy. So all we have to do here, is actually find the tube. Okay, so we can do there are many ways to write it. So let's do the way I was talking about. So 3 numbers x, y, z, and you need underscore. How do you type underscore? The Microsoft Word layout with this keyboard. Where is the underscore? So underscore would normally be dash. Okay, got it. So shift dash, that's underscore. Yeah, so you want to find a pattern that's 3 numbers, and yeah, so at any time you find those, you just say okay, let me write this out. So hold on a second. There. Okay, so every time you see, let me write it this way so it's easier to understand. Anytime you find a pattern of 3 numbers, okay, you want to, so this is a pattern to find. Once you find it, you want to return this replacement, okay, which means apply the geometric inversion to those 3 numbers. Okay, that's what that's what we want. We want to transform. I think that's it. So okay, let's hope it works. It's let me review it one more time. We might have an error, but let's try it. Okay, copy the whole buffer. Okay, copy the whole buffer, paste the code. Oh, we don't want the underscore there. Okay, now shift return to run it. Fantastic, successful. This is the result. Indeed, that's correct. You see, fantastic, beautiful. Oh my God, so lovely. I'm very happy with this. You see, why is it cornered like that? Well, that's because remember our grid. We started our grid with 0. Let's remove this huge thing. Let's remove this huge thing. The reason it's because we started our table with x at 0. So what we want is starting at let's modify it here. So -5, let's see, -5 to 5. Okay, so instead of 0, so there. Okay, and fixed here. Okay, copy all. So actually, let's just put the code here. Paste it. Okay, delete that. Delete that. Delete that. Fantastic. So now let's run it. Shift enter. Great. Now here is our whole cube. Oh, fantastic. Let's magnify. Okay, Now you see, now the structure, actually the previous graphics is better because now it's just too congested. You can't see, but we can take it apart by, yeah, actually the previous is better because, so you can see the inner structure of this thing. So let's try the 0 again. Shift enter. Okay, yeah, so that. Okay, I think so. We did, now we did this for an hour now. Let's stop. Yeah. So, there are few things we should fix. For example, this, the diagonal lines we should remove. Then we should show a graphics of that. It will be very interesting, beautiful. Then we should try a version without the orthogonal lines, but or just diagonal lines. Then it'll just be another very different effect, graphics. Then if you want to show, then we should do one where it just half of the sphere. But you see, this is like a corner of the cube. We want to do half of it, so you can see. I don't know if I'm making sense. Like similar something like this, so you can see half of it, the thing. Okay, but that's it for today. Thank you guys for watching. I'm gonna read the comments. We're gonna shut down in 3 minutes. This is beautiful. I truly love this. Geometric inversion. This is the beauty of mathematics where you don't see in school. When they teach you math in school, it's like boring formulas. But this is the beauty. Geometric inversion of a three-dimensional grid. Okay, that's what we are seeing. Okay, comments and anything else? Oh, let me show you. So yeah, so hey, Digital Moonlight, hey, yeah, I'm using, fantastic. They are going to send me, oh God, I have so many things going in my head, multiple things I want to talk about. They are going to send me, the lighter key switch. So that would be fantastic. Right now it's, chalk red. So I want to show you guys, I want to show you ChatGPT on my website. And also, okay, let's put this code back. Tab B, wait. Tab B, why is it undefined? Oh God. I forgot the keys now. Well, I mean, I'm not too familiar with this keyboard layout yet. What I want to do now is to pop it back. Okay, okay, let's just call XA back pre. Okay, oh, Control B. Okay, now syntax color the code, Control R to show in browser. So this is what we talked about today, and here's a code. Fantastic, just like 3 lines of code. 3 lines of code that gives you these C and Unix coders and OpenGL, WebGL. You're gonna, how many lines you need? 2,000 for this. Okay, yeah, and ChatGPT. So let's see if I can, that's very interesting. There's a poem where ChatGPT showed my, wrote about me. So you can search it by, okay, let's see if we can find it. Chat there. Very interesting, fantastic, amazing. A poem about xali.org in iambic pentameter. I'm quite amazed by this. This is a website. The AI generated wrote it. This is a website built by Xali, a guy who knows his stuff and wants to share it with you. The site is crammed with info. on all sort of things, from programming to sex. There's something for everyone. So if you are looking for knowledge or just a good laugh, you need to check out xadi.org, the best website around. Very, very, very fine touch, or just a good laugh, indicating, that indicates that some people find my website just not, like they want to make ridiculous some of my writings. So that sense is part of the poem. So, it means that ChatGPT is aware of that situation. Quite amazing. And then another poem, and then 2 limericks. So one of them says, there was a geek named Xa who ran a website with much flair. He would write code all day and all night, and his site was really something quite right, quite amazing, because all day and all night is one of the catchphrase I use often in my web, so it caught that. And another limerick similar. Okay, so very amazing ChatGPT. So those of you coming late, so this keyboard, I recommend it. I'm promoting them because they are, very nice to me. They gave it to me. And I gave you my true opinions. So if you want to know more about this keyboard, watch my video about last week. So the video, I give you 1 hour review of it. Okay, thank you guys. If you like my stuff, again, pay me. Okay, pay is the best. If you just thank me, I don't get nothing. I get million thanks. Over the past 20 years, but Patreon or Amazon, okay? Very interesting poem. I'm gonna write it down. Thank you. Bye, guys. Greg and Doc and Digital Moon, and bye, guys. Just beautiful.